Hello, we are now in topic 7, system design, and we are talking about the memory design. We deal with read-only memory, ROM, and random access memory, RAM. Memory is just a storage where we store digital information, and memory is classified differently than flip-flop, even though flip-flop and latches have clock, and so does memory, but the operation is quite different. And memory is actually the driving force behind the Moore's law, where we double the number of transistors every 2 years. And memory consumes majority area and power in microprocessor. So that's why when designing a memory, we have to talk about the cost. We need to reduce the cost, and then for the speed, how fast the data can be read or written into the memory, and also the power consumption. Since memory is a very large data, it has a very large data, so it consumes more power. So we have to design a memory that consumes less power. So in terms of memory family, we can categorize it under random access memory, serial access memory, and content addressable memory. Under serial access memory, we have a shift register, which is the serial in, parallel out. We have parallel in, serial out, data coming in parallel but out in serial. And then we have queue, which is first in, first out, and last in, last out. And under random access memory, we have a RAM, which is read-write memory, which is volatile. And then under RAM, we have a static RAM, which is SRAM, and dynamic RAM, which is DRAM. And we have a ROM, which is read-only memory, which is non-volatile. And under ROM, we have a mass ROM, programmable ROM, or we simply call it PROM. And then we have erasable programmable ROM, which is EPROM. And then electrically erasable programmable ROM, which is EEPROM, and flash ROM. Sometimes the memory is classified under semiconductor memory, and under random access memory, we have DRAM and SRAM, like just now. But for the ROM, if you look here, the mass and programmable is under ROM, but the one that we have mentioned before, the EEPROM, it is fall under programmable PROM. Okay, and flash and byte alterable is under EEPROM because we can erase the data inside the memory. So this is how we categorize it. RAM, which is read-write memory, it is volatile, meaning when there is no power supply, the data will be gone. But for the rest of read-only memory, it is non-volatile, so meaning that the data will be written even if there is no power supply. And for the ROM and PROM, programmable, it is read-only memory, but we cannot erase the data, meaning that the data is being read only. Okay, this is how we put the data using mask during the fabrication. But for the EEPROM and flash memory, this one we can erase the data inside that using electrical mechanism. This is a memory architecture. It is in array, so we have a row decoder to address all the content or the location. We have a bit line over here, which is also called column line, and we have a word line, the blue line here, which is the row line. And since we have a large amount of memory over here, so if you look over here, the address will be large also. Okay, and this type of array architecture can be full into this type of memory. But for this type of architecture, you have to have a row decoder along with the column decoder over here, meaning that if you want to address this, the same thing, this is the word line and this is the bit line, which is connected to each cell. Okay, only that we have to have a row and column decoder. So we move to the random access memory, or RAM, where we have two types of RAM, which is the dynamic DRAM, and static SRAM. Both data can be accessed at any time for these two particular type of RAM. For RAM and VRAM, both are volatile, meaning that when there is no power supply, the data will be gone. And for the dynamic cell or DRAM, it is much simpler to build and smaller. It is more dense and less expensive, but it requires a refresh circuitry because it uses capacitor to hold the information. So the capacitor will leak the power, the value, so you need to refresh the circuit. And the other part is the static or SRAM, which is much faster than DRAM, and usually it is used for cache memory. For dynamic RAM, as I mentioned just now, the data is stored as a charge on a capacitor, so it will be either logic 1 or logic 0. When there is a charge, it is logic 1. When there is no charge on the capacitor, it will be 0. And we need a refreshing circuit or to hold the value that capacitor have. Okay, so for example, this is the structure for one transistor or 1T DRAM. We have a transistor over here, a capacitor over here, and we have address line, okay, or word line. This will be activated to control the transistor. When transistor on, the data will be stored to the capacitor or read from the capacitor. Okay, so the transistor will act as a switch, either it is on or off. For write operation, okay, you have data at bit line, and then at the address line you have to give a logic 1 so that the transistor will be on, so the data from B will be transferred or stored in the capacitor. Okay, and for the read operation, when the address line is given a logic 1, the transistor is on, and the data from the storage capacitor will be sent to the bit line. Okay, and after the bit line receive the data over here, it will be sent to a sense amplifier to determine whether the data is logic 1 or logic 0. So this is the cross section of one transistor DRAM when you fabricate it. So this is the transistor. You have a gate, drain, source. Okay, this poly is your capacitor. This is the layout. Okay, this is the metal polysilicon. Where is your gate, and this is your capacitor over here. That is for one bit only. So you have one transistor, one capacitor for one cell. And in this example, I have a 4 by 4. Okay, 4 word by 4 bit. And this is the row address to decode the address, which line that you want to either you read or write. And this is the output, and this is the sense amplifier I mentioned just now. Okay, this is connected to the bit line. Each is connected to the bit line over here. And we also have a 3 transistor DRAM, 3T. We have first transistor, second and third transistor. The first and the capacitor is similar to the 1T DRAM, only that we have additional T2 and T3. So if you look over here, T1 is connected to write line, but T3 is connected to read line, unlike the 1T cell. In 1T cell, there is only one transistor over here. It is connected to address line, so it can be read or write operation. But for this, write will control T1, but the read line will control T3. So this is more manageable actually. But even though it is more manageable, the area taken is larger than 1T DRAM cell. So this is the one cell. This is example of the layout. So you have the read line, okay, write line, bit line, and ground. So typically this is 16 meg, which is 4 meg by 4, so meaning that you have 4 meg over here, each is 4 bit. Okay, and you have the row decoder, column decoder, refresh circuitry, because we have a capacitor just now, the input output buffer that is controlled by the this line, which is either it is a read column or row read write operation, and this is the multiplexer because we multiplex the address over here. Okay, you can read about it over here. Okay, and this is IC of 16 meg DRAM, 4 meg by 4 just now, and we have a data pin over here, D0 up until D3. It is bidirectional, meaning data can be in and out, and then we have a write enable pin or output enable pin over here, and since it is 4 meg, we need 11 to the power of 11 to address all the location. Okay, and we have row address select, and this one is the column address select, and since it is a 24 pin, we have a no connection over here. And for the DRAM in system level operation, we can have 3 types, which is SD, synchronous dynamic RAM, and then DD, double data rate synchronous DRAM, and rambus DRAM. Okay, so what is the difference between these 3? For synchronous DRAM, it is which is widely used. It exchanges data with the processor synchronized to external clock signal. The data move in and out under the control of the system clock. Okay, so it is a very fast, and the data rate is called single data because the data is sent once per bus clock cycle. But for the SDRAM, it is much faster compared to DRAM, and for DDRAM is much more faster because we have double data rate. The data is sent twice per clock cycle, on the rising edge and on the falling edge. And DDR, which is DDRAM, reads data on both, so the data rate is much faster compared to the single data, and it is usually used in notebook because it consumes less power. And another is rambus, adopted by Intel for its Pentium and Itanium processor, and it is the main competitor to SDRAM single data rate just now. This memory is quite unique because the chips are vertical package with all pin on one side. So if you look over here, okay, so it is assembled vertically. Okay, so we can have a large memory by placing it with this configuration. Thank you.